Hello dear learners, hope you are doing great. Perfect. In this video, we are going to learn how to access the elements of a matrix. In order to access the elements of a matrix, we need to pass on two index positions inside a square bracket. The first index position is for rows and second index position is for columns. Both these positions are separated by comma. So here is an example. A matrix name followed by a square bracket, and within a square bracket we have index position for row and for columns. The element which is at the intersection of the rows and columns index gets accessed. Like vectors, there are many different ways in which we can subset a matrix. We can access all column elements, we can access all row elements, we can use logical vector to access the elements, we can access the elements by column and row names. So let's open the RStudio and write some R code to access the matrix elements. So let's start with a simple one. Here the element of the second row and third column will get selected. In the next example, all the elements from the second row will get selected. So please note, whenever one dimension is left blank, all the values in that dimension will get selected. Now here, the column dimension is left blank. That means all the columns across the third row will get selected. And that's what we are getting as output. We can also access multiple elements. In this case, we have accessed multiple rows. We have accessed the first row and the third row. So here we have used the small numeric vector as a row index position so that we could able to access the first row and the third row elements. Here we will access all elements from the first column. In this case, the blank space is for the row index. So all the rows across the first column will get selected. Similarly, we can access all the rows from the first and second column. Here again, we have used the small numeric vector as a column index position. We can also create a submatrix. So here you can see the element from the first row are actually the intersection of the elements from the first row and second column and first row and the third column. In case of the second row is the intersection of the third row and second column and third row and third column. We can also use the column and row names to access the elements of a matrix. So in this case, we have used row 1 and column 3, and we have got the element at the intersection of these two positions. We can use the negative integer also. Negative numbers will exclude the positions in subsetting the matrix, which is exactly the same as working with vectors. So here the fourth row and the first column will get dropped, and all other elements will be shown as an output. We can also use the logical values. In this case, as you can see that the logical vectors is used to subset a matrix. Check how the recycling takes place. The row index position vector gets recycled to match the number of rows in a matrix. Remember, there are 4 rows in a matrix. So the row index position vector, logical vector, gets recycled, and that's why you can see the row 1 and row 3 are displayed, because row 2 and row 4 are assigned to false. That's why they are filtered out. Let's quickly cover the matrix arithmetic. Let me create these two matrices, M1 and M2. Here is a matrix subtraction. But remember that arithmetic operations, they are performed element wise. Okay, in case of a matrices. The addition, the subtraction, they are all done element wise. The matrix multiplication, it's again done element wise. Here is a transpose of a matrix. That means the rows and columns of a matrix are interchanged. Matrix division, again element wise. But here is an interesting one. Now there is a specific matrix operation here. This is a matrix multiplication. This operation is not carried out element wise. Okay, so there is a specific matrix multiplication rule that must be followed here. So if I execute this, then the error will be shown. It's showing something like non-conformable arguments. So the rule goes like this, that when you want two matrices to be multiplied, the number of columns of first matrix must be equal to the number of rows of another matrix. So there is a discrepancy here in the number of rows and number of columns, and that's why the error is shown. However, in the next line, we have corrected this discrepancy. That means the first matrix M1 has 3 number of columns, and the second matrix that I've constructed has 3 number of rows. So the number of columns in the first matrix is now matched to the number of rows in the second matrix, and that's why the matrix multiplication could be carried out. Matrices, by the way, is a vast subject. There are countless number of ways in which matrices can be used. If you have a look at any linear algebra book, you will understand there are many more applications of matrices. So great, so we covered the matrices. In the last video, we've seen how to create a matrix. In this video, we could able to access the elements of a matrix. The next data structure that we're going to look at are the lists. So lists are the most flexible data structure in R. Let's look at the lists in the next video. Till then, bye.